Index law 3 is raising the power. So if you're given a to the m raised to the power n, the rule for solving this type of indices is copy the base, which is a, and then instead of adding the exponents or index m and n, you multiply them. So it's a to the m times n. Simple. So let's have an example to understand the context of the third law. Okay, let's have the first example. A to the fifth quantity raised to the power 3. So going back here, what you need to do is look back into the problem in here. So the base is a. So copy the base, which is a. And then the exponents are 5 and 3. So multiply 5 times 3. So the final answer would be a raised to the power 15. Okay, let's have another example. This one involves a negative exponent, so 1/2 raised to the power negative 3, quantity raised to the power 2. So the technique here is solve what is inside the bracket first before you multiply that with the exponent from the outside. So we know that the base is equal to 1/2, so write that 1/2. There'll be raised to the power at once to negative 3, 1 to the negative 3, okay, over 2 to the negative 3, quantity squared. If you simplify that, you'll have 1 to the negative 6 multiplying negative 3 times 2 per the law here that we established a while ago, and divide that with negative 3 times 2 would be 2 to the negative 6, right? And we know from the first and second law that if it's negative in here, the exponent, if you put it up, it becomes positive, okay? So we 1 to the negative 6, you multiply 1 6 times, so 6 negatives, that should just be equal to 1 times, that's 2, instead of negative 6, it becomes 2 to the power 6, which is simply equal to, what's 2 times 2 times 2, times you're multiplying 2 6 times, so what would that be? That would be 2 times 4 times 2, 2 times 4 times 2, 8 times 16, 32, and that should be 64. Yep. Okay, the third problem involving variable in here b. So b cubed quantity raised to the power 2 multiplied by base b squared quantity raised to the power negative 1. So what you do is simplify first. So just put it here. So b cubed quantity raised to the power 2 would be b to the power 6 multiplied by b squared to the negative 1. 2 times negative 1 is b to the negative 2. And once again, we use law 1 and law 2. So that should be equal to b raised to the power of 6 divided by, okay, that b to the negative 2, you put it down, you multiply times 1 over b squared, which is simply b squared in here. And use law number 2, a to the m over a to the n is a to the m minus n, yeah? So copy the base b, and 6 minus 2 is 4. So that's how you simplify that problem in there. Okay? Now, I want you to try it yourself. Let's flip this over and try something in here. So quantity x to the fifth, quantity squared, quantity raised to the power of negative 3, multiplied by x to the power of 6, quantity raised to the power of 5. I'll give you 30 seconds to think about it. Okay, let's solve this together. So as I've said, simplify what's inside the bracket first. Okay, so x to the fifth quantity squared would be a to the m times 10. That would be x to the 5 times 2, which is x to the power of 10. Quantity raised to the power of negative 3. Yep. And then times x here, it's only one bracket, x to the 6 times 5 is x to the 30. Now, x to the power of 10 times negative 3 is x to the negative 30. See that? Times x to the power 30. Yep. The negative value, so it's simply saying that you got x to the power of 30 divide that by, negative becomes positive at the bottom, so x to the power of 30. So any number divided by itself, it's equal to, so it's equal to 1. Or you can simply use law number 1 here. So x to the negative 30 times x to the power of 30 would be, copy the base x, and then m plus n, so minus 30 plus 30, that will be x to the 1, or equal to 1.